everyone. I think it demands apologies, which with what I left you in the last session. So let me actually make myself feel better by going through what we did in the last DevLog session. So this is a too long didn't read version of almost 3 hours session that was done yesterday. So I'd like to just put it in short words, what have been done. And if you want to watch mistakes I've made, you can go to the log movie. But actually, this is quite a synthetic thing to go through, and it demands a shorter video as well. So I haven't talked much in a good way about devlog hash 1. Why? Because I don't know, I'm new to that, and also I'm new to Godot, so I'm making some mistakes, of course. And I want to take you straight forward, which I already said. And yeah, we can jump right into it. So when we started, the project was basically in state that we had a map and a player that could move. I can show you. Yesterday we started with the player moving like this and having the attack animation upon space bar. Press and nothing else. So yesterday we did some of, let's go through it. So yesterday we did actually a few things that are quite important in every 2D game, which is animation, for example. So let's cover this one. Creating enemy balloon animation from sprite sheet PNG image downloaded from the web. Cutting it in a sprite 2D. So where is that? Let's take our balloon. So basically I'm gonna close some of this. Balloon I can leave open because I want to show something. Now we are in a world scene. As you can see, this is the root of the scene, and we have children of this scene. So we have a wall, we have a tile map, player, and so on. And we have also a balloon, which I'd like to take care of a little. And the balloon is actually exported here from a branch, like from being a child to a scene itself. By doing that, you then can go into the scene, so to edit this balloon by clicking this, I don't know, movie clip thing. So when you're there, right, there's the balloon. I think I'm making a mistake not positioning him in the 0, but maybe I'll find out soon why this is a mistake. It was just for the visibility of animation, and I don't know, it's just here. And yeah, so what do we have here? We're talking about animation now. So this imported sprite 2D in this balloon, which is being added by @children called sprite 2D. Actually, yeah, under the balloon. We can rename that, call it balloon. And then we have a texture for it. So like a source file that needs to fill this sprite. Let me check if I'm actually being heard.
Is everybody?
Can I hear myself? Yeah. Yeah. That's great. So the sprite object of this type is receiving a texture as like we can call a parameter, and you just grab your PNG file from your project files here, which you can always open in the file manager. And actually, it's a Windows environment, so you can go here, and you can see this balloon walk PNG is looking like ugly this. And yeah, it's our animation sprite sheet, so to say. It consists 3 frames of animation. What do we do with that is, yeah, when what happens when I drag this here? What happens is that we have imported sprite sheet like it is, right? So I move it here. We can hide this old thing actually, and the collision shape of it, and yeah, also this. We can hide it, all of it, by just closing these eyes. And to divide this sprite sheet into 3 separate frames, we actually need to go to the Inspector tab of selected node, which is balloon. Select it now, go to Inspector tab, animation, and choose how many horizontal frames and how many vertical frames. In the other words, how many columns and how many rows are in the sprite sheet file you provided here. I think you may know the answer for this particular sprite sheet. That is 3. Yeah, we have 3 frames, so we enter 3 horizontal frames because they are one to each other from left to right, like columns in a usual sprite sheet. Then we can check the animation and the particular frame by incrementing or decrementing this value, increasing or decreasing this value. Also, as you can see, the coordinations of the frame are automatically updated, which can give you, I believe this is a second column indexed from 0, which is actually a 3rd frame of our animation. The first frame is positioned at 0 frame and coordinations of 0, 0. Yeah, I think that's covered. So then we used animation player. How did we use that? I can actually delete my balloon I created now because this is the same as I had before. So I just delete the node. And going back to our scene, pressing space and moving like this, I actually need to check, yeah, how is it configured. So the animation player, which is under our root balloon node, is having a current animation played in the preview, for example. So I'm not sure if this is we'll cover that soon, but I'm not sure if this is a default state of the animation when the engine runs. Maybe we can check that. Let me check that very fast. So currently we are playing this animation by ourselves manually from the code, which is fine and working. This function is once, it's called once only at the beginning of the scene when the node appears in the scene, I believe, and is ready for further improvements. So currently we are playing this animation, and what about the animation? The animation is defined here in the animation tab of the lower center area of the screen. You can manage animations, add new ones. I have actually this reset is a default one. I could actually remove that, but it doesn't break anything, so I can remove it and have only my balloon walk. So I have it's always default one. So what happens if I remove this one? So this manual thing I'm doing here and run the game. Do they have animation? No, they don't have any animation. So yes, I need to do it manually here. And as we can see, the animation is being played. The animation configuration is quite simple. I think we are covering a few already dots. Yes, animation is quite simple. I would say so. Let's take care of this configuration. So we don't have any animation right here. Let's go to the balloon. Yes, animation player, balloon walk, and the default configuration of it. I spent some time on explaining about the timing, and I can explain it again, of course, and I'll do. But first, I'd like to take cover of some settings I have chosen for this animation without saying probably even a word on it. So this is the looping thing. So when you shut this off and it's grayed out, the animation is going to play only once, I believe. Let me take this. Yes, it doesn't play anymore, but I believe as at the start. Let me move the object and the world closer to the player. Let's actually hide this guy here. Yes, the animation is played once. It stops with this configuration. So let's go back there. Balloon, balloon, animation player, animation. When I do a repeat like this, let's see what do we have. As you can see, the balloon is turning from the 0 to first and to the second frame, and then goes back to the 0 and first and second and so on. So that's not exactly what I want, because I want to be very limited to the number of frames I import in my sprite sheets. So by default, I imported only 3, but I want to show you something as well. But the original sprite sheet has 6 of them. So why did 7? Sorry, 7 frames. So why did I choose only 3? So the reason behind it is that frames to the left, first 3 frames to the left are representing the same state as this, just mirrored by y-axis. So it's mirrored horizontally, we can say. So we don't actually need those 3 frames, but I can show you here. When we add a new layer, I can select those 3 frames, copy them here, hide the whole thing, move it a little, and then I can select it again and rotate, mirror the image horizontally, only affecting selection. As you can see, I have now both directions of the animation setup, and I'm saving the engine actually some memory to load into the game and to parse. And this is very simple to do inside the Godot actually to change the x parameter to -1, which will actually turn the graphics into mirrored mode horizontally. If you set negative y parameter, you would have flipped vertically, so upwards down, right? And this center frame is actually other animation which is a part of dev animation, and this dev animation is starting always with the center frame of each enemy. Some of those have 2 frames to die, but some of them have only 1, and each of these frames starts here. I mean, each of dev animations starts here and ends like this in few colors. So the first frame is like always one of these. No, let me select that. And then dies. We could think of it as this as well. Yeah, mistake, sorry. I can override it. Probably I would need to fill colors for the animation to be consistent about it, so I can pick this color and actually fill it a little here when I put the selection down. So I'll take care of that very quickly, and I'll have an animation for the red guy as well, with some mistakes here. Right? Same for blue guys. Yeah, but that's quite neat. I personally didn't see these guys really in this game. I don't know where are they? Did you see them? Any of you? Because the power-ups are very cool. I mean, shadowing inside the golden power-up is a masterpiece. I think the color take of the 3 colors only, I believe 3 colors here are used. Let me check if I'm correct. Yeah, so I'll be sure of it when I'll add a new palette. It's called Bomberman, and it will consist of 4x4 colors only. So I want to add these colors. This one, this blackish one, and this one. And now I check. Yeah, if actually we match these colors only. Yeah, baby. We match it. How do I know if we match it? It gets white border here in my palette of colors. Okay, enough of this. This was about to be too long. No, too long didn't read for the first part we have covered. So how did we bind and play the animation inside the G script? I already showed that. How did we make balloon move? And that's a neat one. So the balloon has a script, which we actually saw already, but we are sure that it has a script because it's bound here and available through this icon of a, yeah, how is it called? Hieroglyphs? I don't know. How is it called? So basically we are making, we are giving some speed to our balloon enemy. We are sure that we need some kind of vector the enemy is going to be moving. We are sure that we have some height of the viewport. We don't need really to store this value here because it's always available, but we probably don't want to trigger this function each frame and so on. So yeah, it's put here. Why? We'll see in a second. So I made a lot of comments about my calculation mistakes here can be covered out. Yes, this actually has been done yesterday, so I will show you in a second. Yes, I don't need to print this at all, but I can only focus on what's on the code that is working. This is actually my side comment for the GD script language. It's a comment from the creation of the node. So what happens here? When our balloon is entering the scene, this animation is being played. The viewport is being the viewport is actually the window size of the game, and you receive an array of two values. In my case, this is actually 480 per 440, and this can be actually set in project settings, window, viewport width, height. You can choose how does it run and so on. Not really helpful in web deploying, because that's my target to the web, the HTML and JS export, which is native in Godot engine. So yeah, we get this number actually here as the first, the second actually argument of the array, the second element of the array, and the current vector is being set to be a vector from angle. I hope I don't need to explain that a lot. Vector 45 is, as you can imagine, something like this. Yes. Yeah. But let me check that. To the chart. Yeah, that's correct. It's a 45 angle. 45-degree. Yes, I need to make sure. So when you have this as a 0, this as a 90, this as a 180, and this as 270, and this as 360, which is 0 again, you get the whole bunch of numbers between 0 and 360. So when you are talking about making it this vector from angle, you're actually saying that this is gonna be going east-north, right? This is default behavior, and yeah, and in the physics process, the method that is being run in each frame of a game, we are adding a velocity to the actor, to the node, by setting up it as current vector multiplied by delta, which is a time since last frame was generated. Very important topic to cover. And speed, which is set here. We can actually lower the speed of these guys as it was initially. And the move and slide method is generic to Godot. Let me drink some water. And process is this also being run in each frame, but it does not include physics operations, I believe. We'll get to that point. And we have those two functions at the end, and one of them is actually not needed. And I will show you how. I will show you why in a second. These both methods are callbacks for signals that are signals are actually being dispatched here when body enters some body, each body of that is taking part in collisions. Yeah, the body. So we can say that that it is a node that is taking part in collisions, which is a very simplifying definition for now. But when it happens, we are running some script, actually modifying the vector, and the y and x of the vector are being divided by -1, which gives us the opposite direction in the vector. So in our game, when the enemy's blue bubble reaches some of those lines that are set up, and why those lines actually? Because those lines are static bodies to these with two collision shapes of type segment shape, which is a straight line. Not really straight line, but a line inside some yeah, in some you can set an A and B point of a line like this, yeah, 2 points, straight line. And they are a part of static body 2D, which is having a collision layer in physics set to third bit with value of 8. This is our layer 4, which has no name by now. Those 3 layers have received names, and we can actually go and check that. And these are outer walls, horizontal, and these are outer walls vertical in our case. So whenever our wait a second, balloon. Yes, balloon has its own a collision shape, and it has an area 2D attached as a child node with collision shape of circle shape 2D, which is this circle represented here. We can actually move the sprite upwards, I believe, as much as possible, so we see it the best as we can, and it's not affecting the other things, I believe. And we can see that our vertical borders are emitting the signal. So we can see that the signal is here. Connected to this particular method, which is not saved, so it pointed me to the wrong place, but when I click it now, yes, I'm taken to this place. And this one is not actually bound to any signal at all. It was bound to this node before I renamed it to vertical borders. Before it had generic name area2D, which it always has when you create one. So when you would like to create some signal for it, it would probably overwrite my method, but let's not go there. I can delete this one, and yeah, I am only having this method in use here. So whenever I reach the collision layer of value 8, I change the y direction of my vector, of my current vector, moving my enemy in his y property to a negative of it. So it like bounces from the collision body he collided with. If it's in this group, and also if that happens to a body that has collision layer of 16, we change the horizontal part of the vector, which is x prop. Okay. Okay. We have talked a little about collision masks, and we can also see that this vertical border, which is actually the circle around our balloon, is colliding. I mean, by colliding, is having a mask of collision with outer walls H and outer walls V, which is 4 and 5, and actually 8 and 16 as a value, which you can see as also here, value 8, value 16, when you hover on it. And this is a bit representation, so the values go to yeah, I forget some really important words. Yeah, so 2 to the powers of 0, 1, and so on. Bits usual, right? Okay. So our vertical border with circle shape of that size, we can actually make it smaller a little, is going to collide with our bodies that have collision layer set to 4 or 5. And that being said, we can see that actually our static body 2D, which is this one, these are vertical colliders. And these are horizontal colliders. And actually I made wrong naming in layers, so let me take that better. Yes, V. Yes, they are in layer 4, and this one, this group, I mean this static body 2D has colliders of 2 lines, which you can see with the red dot selected here and here. And those are horizontal colliders. So when we run that, our balloon can move, but the second one can. Where is he? Yeah, he's going somewhere. He should be changing his direction when he reaches the bottom line, but maybe he doesn't. Yeah, he should. Yeah, he reached it and he is going back forward. Can he move through me? No, he can't. But he can't kill me as well yet. And he's going upwards, probably to this point. He will be bound again from this collision lines here somewhere. You can see that in a second. You'll see that in a second. Actually made it here already, so he's going back. Yeah. Okay. So that's actually what we covered in the first devlog. What is going to happen next, you can read it here. Especially I would appreciate some help in pixel art. So very well, thank you very much. See you later.